Welcome back, everyone. This is going to be an explanation of single replacement reactions. This is worksheet number 5 in your packet, and it's going to require you to use the activity series of metals. In this activity series, you will find it included also right after your periodic table in your packet. So in case you don't want to use your notes, I know it's very small in those boxes. You can go back to your beginning of your packet, and it's right there behind the periodic table. Okay, so a single replacement reaction is going to take place when we replace a single element in a compound. So originally, this is going to look something like if I have individual element A and I add it into a compound, the A, if it is a metal, we'll replace the metal in the compound, and what we'll be left with is the metal that was originally in the compound by itself, and then a new compound where the metal was replaced. And so again, this is going to be an element, this is going to be a compound, and we create a new element and a new compound is the way to see this. And again, a metal can only replace a metal, a non-metal can only replace a non-metal, so keep that in mind as you're going through these problems. A good example of this type of problem is if we were to take something like lithium and add it to an aqueous solution of zinc acetate. Now, keep in mind, lithium is a metal, it is solid. Zinc acetate is actually a liquid or aqueous compound, and it would have to be in order for this reaction to occur. We couldn't put lithium, which is solid, and add it to something else that's solid and expect a reaction to occur. We have to take our solid lithium, add it into our aqueous or liquid zinc acetate in order for this to occur. Now, does this reaction occur? That's what we have to ask ourselves, and that's where this activity series comes into play. We have to make sure that the element that is going to be doing the replacing of the other is listed higher on the activity series of metals. And so if we take a look, lithium is actually listed higher than zinc. So in this particular case, lithium actually could replace zinc in this compound. So what we're going to be left at in the end is going to be a compound that consists of lithium acetate, and the zinc metal is now going to be by itself. It doesn't matter which part you write first. You can write the compound first, you can write the metal first. It really doesn't matter in terms of this type of equation, just so that you actually show the lithium is now taking the place of zinc in the compound. Okay. Another example of a replacement reaction is going to be if we had something like copper, which is a metal, and we're going to add it to aluminum sulfate. Again, before we actually see if this reaction occurs, copper is a metal, aluminum is the metal. We have to make sure that copper is listed higher on the activity series, and if it is, it can replace aluminum. So let's go ahead over here and we'll take a look. And when we take a look at the activity series over here, we see copper is located here at the bottom, and aluminum is located here at the top, or towards the top. What this means is that copper is less reactive than aluminum, and so therefore copper could not replace aluminum in this reaction. And so what would happen is that no reaction would actually occur. So anytime you have a metal that's trying to replace another metal in the compound, and the metal like copper is less reactive, no reaction will actually occur, and that is what you are going to write on your worksheet if you find or run into one of those types of problems. Another example would be if we take a compound that is lead 2, because remember lead is a transition metal. It doesn't have a known charge, so we have to include it when it's part of a compound. So lead 2 carbonate, and I'm going to add barium to that compound. When I add barium, again, I have to make sure that barium, which is a metal, can replace the metal in the compound. Is barium listed higher on the activity series than lead? So let's take a look. Here's barium, Here is lead. So therefore, barium actually can replace lead in this particular equation. So then we would write barium, which does not need a Roman numeral because it's under a known charge column. We would write barium carbonate, and we would write lead now by itself. You do not need to include the Roman numeral with lead when it is by itself, only included when it's in a compound. Just a few brief notes as well about these single replacement reactions. You'll notice sometimes that water is a part of the compound. And if you see water in your equation, change it to hydrogen hydroxide instead of calling it water. Reason being is because hydrogen is going to be the metal. And so you can tell if something can replace hydrogen in the water because hydrogen is listed down here. As long as the metal that's trying to replace hydrogen is listed above it, then it can replace it in water. Okay, so you'll have hydrogen in the end by itself, and then whatever is going to be combined with your hydroxide. The other special unique category is if you have an acid. Acids always start with hydrogen as well. So when you come upon an acid, okay, of some sort, make sure that you change the acid to say hydrogen in the beginning. Again, if whatever you're adding to that acid, let's say that you're adding tin to phosphoric acid, so we would call that hydrogen phosphate. So if you're adding tin to hydrogen phosphate, the tin is listed higher on the reactivity series, okay, than hydrogen, so it will replace it. So in the end, you would have tin phosphate. We'll call this tin 4 because we're not sure of the Roman numeral, and along with the hydrogen now being by itself. The last part of this activity series in these single replacement reactions deals with the activity of nonmetals. And there's only 4 nonmetals that are actually listed, and the nonmetal activity series is in your notes. And those are fluorine, chlorine, bromine, iodine. Same rules apply here. If I'm trying to replace one nonmetal with another, it better be higher on the activity series so that that can happen. So a good example is something like potassium iodide, and adding chlorine to it. Now, again, chlorine is a nonmetal, iodine is the nonmetal in the compound, so we have to figure out, can chlorine replace iodine? Well, if chlorine is listed higher on the activity series than iodine, then it will happen. And just so happens that chlorine is listed higher than iodine. So when I would rewrite this, I would write this as potassium now combined with chlorine, but we change the ending always to IDE in a compound, and iodine is now by itself, and we're going to leave it as iodine because it is by itself, not part of a compound. All right, so that's single replacement reactions. If you have any questions, please let me know.